All right, you guys, some of you asked for more examples with the quadratics. So I thought we can definitely do them in class, but I also thought it might be kind of nice to have a few more examples that you can watch and try on your own. So after looking at the last video lesson, I showed you both methods of looking at quadratic functions. I'm going to do another example. I'm going to do the same example maybe both ways. So starting in reverse order, one of them looks at using the quadratic formula. So if I give you the quadratic equation, okay, ax squared plus bx plus c, we can find the quadratic formula to solve. So the quadratic formula, I'm not writing the whole thing out, we have before. X equals opposite of b plus or minus square root of b squared minus 4ac, all underneath the radical sign, all over 2. Okay, and then we said there were a few things about this to keep in mind. One of the first things is to notice the front end. I could write this as the opposite of b divided by 2 and the square root of this discriminant divided by 2, because that's how you add fractions. You have a common denominator. So if I look at the front end of this, notice this says x equals. Well, x equals is a line. So this will always be your line of symmetry. Once we have our line of symmetry, we have half of our vertex, but I'm going to come back to that. So I'm going to leave this blank. So leave a space on your notes blank, and we'll fill it in as we go. Okay? So let's take a look at one, and I'm just pulling one from the book, which I have right here. Let's just pull number, I'm trying to think of one that might factor nicely, or, okay. Which one do I want to do? Sorry, I probably should have been a little more prepared. I was just trying to come up with one. Yep, we'll do this one. This is number 44. I was glancing to see if the numbers were going to be relatively nice. I hope they are. 44 says f of x equals 2x squared plus 5x plus 3. Well, if I use the quadratic formula, and I kind of like to, if this leading coefficient is not a 1, if it's a 1, I complete the square and do it the other way. But in this case, okay, I'm going to first start with find the line of symmetry. Find the exact middle value of our parabola. So I'm just going to follow the directions. All right, line of symmetry, x equals opposite of b over 2a. Our b value is 5. We have a, b, c. So I get the opposite of 5 over 2 times 2. Well, maybe that one's a little messier than I thought. It's okay. So I'm going to start there. How much room do I have? Negative 5/4. So I'll be on the left side, so that's good. How far up can I go? About there. There's our x. There's our y. Okay. Now, negative 5/4. That's the same as 1 and 1/4. So 1 and 1/4 would be right about here. All right, so if x is negative 5/4, that means my line of symmetry right now is a vertical line coming right through order to figure out where on this graph I'm going to have this square function that is positive, so it's opening up, I need to know where along this line it's going to be located. I know the x value is -5/4, but I need to know what the y value is in order to find that minimum value since it's opening up. So I'm going to, quote, plug it in. I know the x value is -5/4. Well, now I have to calculate the y value. All right, f of -5/4, let's just substitute it in. 2 times -5/4 squared, 5 times -5/4, plus 3/1, because it looks like I'm going to have to add fractions, so I went ahead and changed that to a fraction. This gives me 2/5 squared is 25, over 4 squared is 16, 25/4, 3/1. 50/16, I have to have a common denominator. Common denominator is 16, so I'm going to multiply the middle fraction by 4/4, which means I have to multiply my last fraction by 16/16. That way they all have a common denominator of 16. Oh, I guess I could have reduced it. Bummer. I guess I'll reduce at the end at this point. I apologize, I did not do that on purpose. I could have reduced the 2 and the 16 to have a common denominator of 8. 50 minus 100 is -50. -50 plus 48, -2. So it looks like our y value, when I reduce, is -1/8. Difficult or tedious? A little tedious. Not difficult. We've added fractions since 5th grade. We just organize our work, it'll be fine. So here's -1, here's -2, here's a half, a fourth, 3/4. So it's at -1/8. So here's our vertex, and it should be opening up because this is a positive number, so that square function will open up. So once we've found the vertex, we can now move on to 2 other, 3 other, 4 other points on the graph. So I have our line of symmetry. We have our vertex by taking whatever our x value was and calculating the y value by substituting it in. After that, personally, we're almost done. Let's just find the intercepts. Okay? Easiest intercept to find, the y-intercept. It's easier because we set x equal to 0 and solve. Okay, let's do that. Y-intercept, set x equal to 0 and solve. So let's find f of 0. You can do this mentally. Substitute in 0, first term is gone. Substitute in 0, second term is gone. I'm only left with 3. So I now know the y-intercept is 0, 3. Which means, because it's symmetric, I know that there's going to be a point on the other side of the line of symmetry that is also the same distance from the line of symmetry. So if this is 1 1/4 to the right, Then I need to go 1 1/4 to the left. So our fractions are going to come into play. So 1 takes it all the way to 2 1/4, and then I have to go 1/4 more, because remember this is 1 1/4. So 1 1/4. So that is -2 1/2, 3. So technically, I have enough points to create this smooth curve. But I'm going to find 2 more points. I'm going to find the x-intercept. Now in this case, I'm guaranteed 2 of them because this is opening up. Since the vertex is below the x-axis, when it opens up, it's going to hit twice. And in this case, I'm going to use the quadratic formula to solve. You don't have to. You could start over and factor. Actually, this one factors. This one factors. Or factor. Or complete the square. You can use whatever you want. Okay? Feel free to use quadratic formula. Feel free to factor. Feel free to complete the square. I wonder if I should just... Now I'm going to go ahead and factor, since I told you I would. So x-intercepts, set y equal to 0 and solve. So y equals 0 equals 2x squared plus 5x plus 3. And you may be saying, how did I know it's going to factor so quickly? Well, to refresh a little algebra, if I take this first this first coefficient, and I multiply it by the very last number, if I multiply the a times the c value, when I multiply, I get 6. Okay? The middle term is going to be a 5. So what we want to find is, we want to find what are factors of 6 which add to 5. Factors of 6 which add to 5 would be 2 times 3 gives me 6 when I multiply, but when I add I get 5. So as soon as I can find these two numbers, I'm guaranteed it's going to factor every single time. And the way we worked with the algebra teachers is rewrite this middle term as 2x plus 3x. So 5x is the same as 2x plus 3x. And now what I have is I can factor by grouping. If I group the first two terms together, and then I group the last two terms together, I'm going to use the distributive property and take out what they both have in common. That's called factoring. Both of these terms have a 2x. So I'm left with a x plus 1, which means when I take a 3 out, I'm also hoping to get an x plus 1, which I do. Therefore, the common factor they both have in common is that group x plus 1. And since we are solving, remember this was set equal to 0. Right here. So from algebra, if two things equal 0, the only way that can happen when they're multiplying is if each factor is 0. So that implies that either 2x plus 3 is 0, or x plus 1 is 0. So that means my answers for x are either negative 3/2 or negative 1. X is either negative 3/2 when y was 0, or x is negative 1 when y is 0. So if I graph those x-intercepts, negative 3/2 is 1 and 1/2, negative 1 and 1/2. The other intercept is at negative 1, 0. And now that I have the intercepts, I can now make a smooth curve So hopefully that helped. I want to give you that example. I'll insert that in. One more example using the quadratic formula technique. It starts from the line of symmetry and works its way out. It does have a minimum value. The minimum value is just the y value. So the lowest point on the graph is negative 1/8. There is no maximum because it goes forever. No maximum. But the minimum occurs at that y value right there. So I have an interval of decreasing coming down from negative infinity all the way to negative 5/4. It hits a minimum value of negative 1/8. And then it has an increasing interval from negative 5/4 to infinity. So hopefully that example helped you guys. Be sure and ask if you have any more questions during class or our reviews.